All right, you guys, here's a review of checkpoint 1, but it's also a good example of how to take a quadratic table and how to recognize a quadratic table and turn it into a graph, an equation. And I'll tell you about a situation, but really if you just have the table and stuff, you're only going to be thinking about one piece of the situation. So let's just go over what we have here. In order to make the table, right? In order to make the graph, we just need some points from the table. So those points are the x and y intercepts, and also the vertex, which comes later, but the x and y intercepts for sure. You can find them in the table. So the x-intercepts, let's do the x-intercepts in green. The x-intercepts are when the y is 0. So actually, let's do this. This is the output. This is the y, or the output here. Okay. So if my y is 0, then the x value, the input at that same place, is the x-intercept. So there could possibly be 2 when I know that this is a quadratic equation, and there's the other one. So I have 0 and -3, and 0 and 5, and those are the x-intercepts. And then let's use a different color for the y-intercepts. Use pink. The y-intercept is going to be pink. The y-intercept is going to occur when the x value is 0. And if something is a true function, there's only going to be one of those. All right? So there it is, 0 and -15. So let's go ahead and plot those points on our sketch. Let's see if I can get this right in there. Okay, so -3, let's make actually, so +5, and then let's say that would be -5, 1, 2, 3, 4, so this would be -3, and my y-intercept is -15. So I can already kind of tell from what's happening that it's going to be a positive parabola, that both sides are going to be headed up here, because that's really the only way to hit all of these points. Now there is, and actually I'm going to redraw that -15, because that -15 is not our lowest point. It is just our y-intercept. So I'm going to make that here, because I don't know yet what our vertex is. I don't know yet what our lowest point is going to be. But I do know that the x value is going to be directly in between -3 and -5. So if I find the average of those, or the mean, I would take -3 plus 5, that answer divided by 2. So that ends up being -3 plus 5 is +2 over 2, which is equal to 1. So that's going to be 1, 2, 3, 4, 5. That's going to be my line of symmetry is x equals 1. So if I drew this line, it doesn't show up in the graph, but if I did draw it and I folded it, that's where I could fold that parabola and it would match up on both sides. And that is my x input. And luckily we have this table here, so I can go over and look and say, oh, when x is 1, my y is -16. And I already know when x is 1 that that's going to be my vertex. So my vertex is actually -16. So if you're thinking to yourself, and then I can draw this here, if you were thinking to yourself, well, why couldn't I just look in the table and see that that was, let me finish drawing this here, and see that that was the, and don't forget, it's not a hole, these are going to go up forever on both sides, okay? Why couldn't I just look in the table and say, like, oh, that's the lowest point for y in the table? Well, you kind of see that that's the lowest point, but we only have whole numbers on this table. And this graph represents all numbers. So what if it was the lowest at 1.5? What if it was lowest at 0.5? We just don't know. We had to figure out the mean and then say, okay, yes, when x is 1, that is going to be our lowest point. But we had to prove that. We couldn't just take the table since it's only whole numbers. It's not all numbers. we had to prove that that was going to be the x. Did you guys know between 0 and 1, there is an infinite amount of numbers? Between 1 and 2, there's an infinite amount of numbers. So in order to really find that vertex, we had to do that. So that's how we made our graph from our table. We found 4 points. That's how you do it. You find 4 points from that table. Moving down, making our equation, now that we have our zeros, now that we have our intercepts, right? So for this one, don't forget to write this -1, -16. Oops, +1. There we go. Okay, now that we have our zeros, we can create our equation. Okay, so if it's not being stretched at all, what that's going to be is we know the formula. Well, I don't know if I ever actually gave you the formula, but the formula is x minus √1, x minus √2, and that's factored form. So what we know is we have x minus, our first root was -3, okay, and then our second root, we have x minus was +5. Okay, well what that simplifies down to is y equals, I'll put this over in the equation, is y equals, minus a negative ends up being x plus 3. And over here we have x plus 5. So those should be the opposite, oops, sorry, -5 I mean. These should be the opposite values there. +3 and -5 should be the opposite values of your zeros, because what we're doing is we're subtracting them. Now, just to make sure that we're not multiplying this equation by anything, to make sure that it's just going to be a normal equation, which we'll get into later, but I'll show you. We know another point. We know our vertices. So we know if we enter in, and let's just check this, if we enter in +1 for x in both x's, if we input +1, our output needs to be -16. So let's see if this works. +1, let's figure out if y is correct. +1 plus 3 is +4. +1 minus 5 is -4. -4 times +4 is -16. So good, that worked out. We didn't have to find another number. We will work on finding other numbers later. So this is our y-intercept. We already found that out. Now, what I liked is a lot of you guys at this point said, I want to write it in standard form. So you just multiplied this factored form out, and you got a second form of your equation, which was, let's see, x squared, 3x minus 5x. I'm sorry, this wasn't our y-intercept, that was our vertex. Minus 15. And that ends up being, when you simplify it, x squared minus 2x minus 15. And then you can see our y-intercept in this form of the equation. So we've taken a table, we've made a graph, we've made an equation. Now let's talk about the situation. The situation is going to be easiest to see in, oh gosh, I wish I could get this perfect, in the graph, okay? And we don't have a specific situation, but we know what's happening is that some number's going down, and then it's going to come back up. So if you can think of any type of situation where something's going down and then going back up, you can pretty much use a quadratic formula to represent it. Maybe you're dropping a ball and it's bouncing back up, okay? You could write an equation where you're dropping a ball and it's bouncing back up, and it could be something like this. You could write an equation for, like, if you look at this looks kind of like a, I don't know, a canyon. You could literally write the equation for the canyon, okay? Because that's what it looks like, and that's fine. So in this case, we don't have a situation, but if you were forced to make up a situation, it would need to look like the graph, and that's what you're thinking in your head. All right, you guys, that's it for this one.